All right, this is the second one that's in the notes. All right, I'm going to read it, go kind of slow. If you're at home, you can screenshot it on Zoom. If you're in the room, you might want to write it down. All right, it says example 2. It says you throw a ball straight up from ground level with an initial speed of 39.2 meters per second. Okay, so they're always going to give you that extra information in these. All right, you just have to know that, okay, that's probably not going to be something you're going to need for the actual story problem. The function s of t is equal to negative 4.9 t squared plus 39.2 t. Okay, now notice this one was thrown from ground level, and there is no number, there's no constant at the end of that quadratic equation. All right, there's no constant here, which would be a plus 0 because it's thrown from ground level. Okay, and then there is the initial speed right there, 39.2. So it's automatically in that equation. All right, it describes the ball's height above the ground, s of t in meters, t seconds after you throw it. How long is the ball at or above a height of 34.3 meters? Okay, so this is how they change. Okay, this is how the question is going to change. They're not all going to be exactly the same. And no, I'm not going to be able to do every question that you're going to encounter. So this is where you'll have to make a little bit of adjustments here. Okay, but if you want to draw a picture and think about this for a little bit. Okay, here's our ground. All right, so you throw a ball straight up from ground level. Not really necessarily the best application here, but you throw it up, and what's it going to do? It's going to go up, and then it's going to come back down, right? So again, what would I have here? All right, well, that should be right there. I didn't draw that right necessarily, but you're here at ground level, you go back up. That really should have been the axis right there. Now, for how long is the ball at or above a height of 34.3? All right, well, at some point on here, there is the 34.3. All right, so from this moment in time to this moment in time, however much time that is, all right, it's at or above. So it would be the time that elapses between here and here. So I'm still trying to solve for t. All right, I still have my original equation. So this time I'm going to go ahead and set it equal to that so I know when it is at that or above that. So I'm going to go negative 4.9 t squared plus 39.2 t. All right, and then I'm going to say, okay, is equal to the 34.3, which is that number right there. And as you recall, when we were solving equations, what do? We move them, all the numbers over to the left. All right, set it equal to 0. So I'm going to take this 34.3 and move it over to the left. So negative 4.9 t squared plus 39.2 t minus 34.3. Now I've got a nice little quadratic. It's on the left-hand side. Okay, again, a negative leading coefficient, but it has to be because we're dealing with something, a projectile of some sort, so it has to be an upside-down parabola. So I know I'm going to take out negative, probably a negative 4.9. We'll go into each one of those, I believe. Yep, negative 4.9. So you factor that out, you'll be left with a t squared in that first one. When I take out a negative, that means I'll have a negative, and I believe this comes out to a nice little 8t. All right, and then I have a negative. I'm taking out a negative. It'll be a plus, and I believe that's 7. So the one good thing that they will do for you is whatever equation they give you, they're going to factor because that's the technique that we've done up to this point. We've taken our quadratics and we've factored them and solved them, so they're going to be nice like this. All right, the negative 4.9 is going to stay out there in front. All right, I'll have a t and a t. We need to factor this. The only way to get an 8 would be to do the 7 and the 1. Those are your only factors for 7. They both need to be negative to get the negative 8 in the middle. 2 negatives make a positive. All right, so again, this is a plain number out in front. When I set that equal to 0, it doesn't make sense. So that does not give me anything. This right here gives me a t equal 1. And this right here gives me a t equals 7. Okay, so right here, it's t equal 1 second. Right here, it's t equals 7 seconds. All right, so I want how long is it at or above? All right, so all of this time, which would be everything in between there, which is what, 6 seconds? Because if we're at 1 second and we give 7 seconds, it's 6 seconds. So we are at or above that for 6 seconds. So just because you get two numbers, the answers are not to this particular question. The answer is not t equal 1 second, t equals 7 seconds. You've got to take the actual answer to answer the question. They want to know for how long. So that gap, how long was it in the air? Well, it was in the air for 6 seconds. So that's the main thing. Don't try to just think every one of these story problems is going to be, oh, I just have to take the quadratic and then solve it. And then whatever my answers are when I solve it will be the answers to the story problem, because that's not always the case. Okay, that's not always going to be the case.